Right, so we're looking at tutoring questions submitted for Thursday. Again, we are looking at all pre-calculus questions, transformations. So we have 856 app. So let's go ahead and just dive right. I'm going to zoom in here. I'm going to first ask to graph the same coordinate axes. And what I'm going to do is graph the using transformation. So I want to point out, I have seen that they're just kind of like they're numbers. Actually, plotting x's and y's graph, not but I can strength doing this our transformations thing we're doing from my ruler straight axis. So all right, so I'm going to start with parent graph, so 1 over x. So the parent graph is really the one that you should be kind of making a little xy chart for, because that's going to be your very basic. So I know that 0, it's undefined there. So that's where vertical asymptote. Okay. If I plug in 1 over 1, I'm going to label my point. Also important, label your points. Don't just draw a random line. This is garbage. I don't know where the points are going. I don't know if you don't know how to draw a straight line. Maybe that's a straight line to me. No, it's not. Look at the curve. I don't know what your intent is. So make sure that you are using coordinates, labeling. All right, so grab another point, -1. 1 over -1 is -1 here. And we can keep graphing more points, but I'm only going to plot the rest of the points on this graph are going to be fractions. So if I plug in 2, the answer is a half. Plug in 3, the answer is a third. Those are going to be very hard for us to kind of graph. So I just kind of stick to graphing only the nice points. You know what the graph will take shape like. So there's my parent graph. So when we graph, we want to make sure that we plot at 3, I'm going to say points of interest. So what I mean by points of interest are, so we have these two. You might be saying, well, what's the third point? Remember that I said the asymptote is 0. Okay, so that's really a third point of interest. It's going to be graph is the asymptote. So I really have 3 things that I can point to that now I'm going to use the power of transformations. So now when I look at this here, this second function, g of x, I could make an xy chart again, but that's going to take time. All right. And the more transformations there are, the more time this is going to take. And I have no guarantee that it's going to come out to a nice data plot. So we're going to just use transformations. So according to this, a transformation is take our first graph and we move it down. That's easy. I already have the points here in front of me. So I'm just going to move it down. So I'm going to make this be a green graph. So I'm going to show that here. So I'm going to take this coordinate and I move it down 4 points. It's going to be somewhere down here. So this will be at 1, comma, -3 down. This would be down. Well, put it at -1. -1. negative. Okay, so this is just a vertical shift. It just moves the graph down. So I know that the shape of the graph is going to be the same. It's change. Now, there's actually another part to the graph that is, we know that this was getting close to the x-axis and the same thing. So actually, there's was a fourth point of interest, and that was the x-axis, horizontal asymptote. Guess what? That horizontal asymptote, it also moved down for. So I'm going to plot that here. So it's now also well at negative. Was at 0. It also moved down for you. Vertical asymptote is a vertical line. Moving it down 4 units, we're not going to see anything like that. It's now black graph I'm going to have for now. What do we see? Oh, it's two transformations. I'm going to use transformations to help me graph. So for the blue graph, how did I change? Well, I moved the left according to, and then down 1 unit according to here. Over 3. I'm going to do that with all of our points. I'm going to move over 3 units and down 1. So over, put it at, then down 1 would be at 0. Label it. The vertical asymptote will do the same. It 3 and then down 1. So down ain't going to do 3. Now that vertical asymptote. This, the horizontal asymptote is moving it over 3, so set at 0. Then down 1. Now we can visually see that vertical asymptote and the horizontal asymptote. And then this point, -1, -1, also 3, and then down 1. So over 3, so it makes it negative, and then down 1 unit. Sketch. I can make that was also bad. Try. Times a try. There we go. And there. Sketch. So now we see, we transformed that. I can literally see from the graph, the black graph. So you can see here, I'm using transformations, and I was able to graph it a whole lot faster than if I would have sat here and gone x, y, and picked x values in here. Was it, oh, x is, I would have had 1 minus 1. Is that a nice number to plot? Okay, let me try 1. Okay, I plug in 1, now I get what? Oh, 1/4 minus 1. Ugh, another ugly. By ugly meaning it's not an integer number. So I can sit here all day trying to find the nice integer number that if I would have plugged it in, it's going to give me a nice answer. Or I can use transformation, because if it started out as a nice number, when I do my transformations, hey, guess what? I land at a nice coordinate. This is the power of transformations. So be a convert. Learn to love transformation. Stop using X and Y charts. Want to use X and Y charts? You can use it to check your work. Like, oh, does -4 really give me a -2? I can check, plug it into the function, verify you did the transformation right. That's really what you should be at any time you actually plugging in. Okay, now let's look at 56. So 56 and 9, yes. there were four parts to it. There was graphing and describing of the transformations, writing G in terms of F. So I'm not going to do the graphing part because I did it here with. I am going to do the other parts, which identifying the parent function, um, describing the transformations, and then also writing G in terms of F. Did a lot of practice with writing G in terms of F in class meetings that we had today and yesterday. So I put links to those class recordings up on classrooms. Take a minute if you weren't in class or you kind of forgot. Go back, watch the videos. So let's get into this G of X. So first thing I'm going to do is identify is so the parent function is not a transformation. So the plus one, the times a negative half, that's not part of, or sorry, those are parts of a transformation. I know what this transformation is not, but this cube is not anything transformation. So that indicates to me the parent function labeled x. The parent function is x. Everything else outside of the cubed is something that is transformation, multiplication, subtraction. Those have to deal with some form or another of. This is our parent. All right. Now let's describe the transformations. I'm going to write down the transformations in no particular order. So I see there's three things I got to discuss. There's this plus one, and then there's this times negative a half. And when I doing this multiplying by a negative half, I'm actually going to look at it as separate things. Negative, and then there's the half. Three transformations. So the first transformation I'm going to tackle is I'm going to talk about this negative rate. That is a reflection. So watch the videos with regards to transformations that I had done earlier where I kind of talked about all three types of transformations, how to identify them, function. Multiply by a negative. Negative itself, not the number, the negative itself is outside the function, reflect over the x-axis. Now the half, that's going to be a vertical compression because it's a number that is less than 1. So I'm multiplying by a number that's less than 1. That is a vertical compression. Now I have to be specific. So I wrote this in, commented on people's homeworks. People would just write vertical compression. That's not enough information. How much did you compress by? If all you just write is vertical compression, that's not enough. Some people just wrote compression. First off, I don't know by how much. Secondly, I don't know in what direction. Vertically compress, horizontally compress. Be specific. There should be numbers. The only transformation that does not take a number is a reflection. It still requires a direction. I just can't say, oh, I reflected it. You have to say, oh, you reflected it. Where? Over what axis did you reflect? So vertical compression, and I'm going to say vertical compression by a factor of 2. So here's another thing that I saw some people make mistakes. They would say vertical compression, and they would say by 1/2 or by a factor. This is like saying a double negative. Like I am not going to be there. So that means you're going to be there. Since we're already saying compression, that already means we're going to divide by 2. If I write vertical compression by a factor of 1/2, you're saying I'm going to divide by 1/2. You divide by 1/2, that means what? You're multiplying by 2. You don't want to multiply by 2. We want to say what? We want to divide, compress, by 2. So this is why in the notes, the video I showed you, look at again there where I stated this, how you state that factor. So vertical compression by a. All right. Now the plus 1 side the function, adding, and we're left 1 unit. There's my list of transformations. Now, discussed the other day, order. The order in which I do the transformations matter. Yes, I have to follow operations. According to this, if I were plugging in a number, first thing I would do, add that 1. This, transformation number 1. Then after I do that and I carry out the function, increasing its power, then there's this multiplying by a negative. Really, these two together, I'm going to actually say is transformations 2 and. So I'm putting it like this because since they're both together like so, they're both multiplying together, I split it up to describe the transformation, but really they're happening together at the same time. So it doesn't matter which one you do. You want to reflect and then do the vertical compression, or if you want to vertically compress, then reflect, won't make a difference with the picture. Right. What is going to make a difference is, oh, I got to make sure I do that horizontal shift first. That's got to happen first. Then these two, they can go whatever order they want because technically both of them multiply. So that's describing information. Now, the third part is, how do I write G in terms of the parent function? So in class where we looked at, okay, what I have now, where I want to get to. What's different from here? Oh, there's a plus 1 in the function. And then there's times negative half outside the function. This, how I would g of x, f. The f is going to take care of that cubic part. That's the part, that's the only thing that's missing from me. You might look at this and go, why didn't you write a cube? Because I wrote f. F is x cubed. Oh, I'm going to take this. Gotcha. That's what then this. All right. So now let's look at 9, which is the same exercise here. First, I want to identify the parent. What are things that I can see are transformations? Plus 8, the minus 9 transformations. This 1 over 1 divided by x, I can't link that to a transformation. It's not a vertical stretch, it's not a compression, horizontal stretch, horizontal compression. So that's got to then be my parent. So my parent function is f of x. All right. Next, what are the transformations? Problem, there are transformations. There's the moving to the left 8 units, and then this minus 9 after the fact, so down 9 units. Again, specific with the transformations. Just don't say move left to move down. How much did we move down? I also don't just say 8 units. I need a direction. Oh, okay, I move to the left, I move to the right, I move down, I move up. Vertical to horizontal. Now, order of operations, what would happen first? So if we plug in a number, what would happen first? That plus 8 be my first. Minus 9 always follow. Figuring out order, transformation, follow curve up. Curve transformations, curve operation. All right. Now for the last part. How do I write g of x in terms of f of x? So, what's different from here that I see? I see, oh, I'm adding an 8 inside the function, say f of. plus 8 side of my vision. And then after that's done, that's what I'm looking for. What's different from parent function to the given function? Now, again, in class, we did a whole bunch of these. So, again, go back, watch the class video. I did some that were even harder than the book just to really check if you kind of understood the concept. Again, we were really firing on all cylinders there with identifying it. Some of you chimed in. So hopefully, if you still weren't getting it, back, watch the video. That way you understand that I did quite a few, 6 or 7 different in. So that does it for our tutoring questions. Again, these are done on Tuesdays and Thursdays. So if you have any questions, mail those in, and I will then record a special video like this. I'm specifically questions.